Hey, welcome back. So a lot of people have been asking me, how do I take a large language model such as llama-2 and then fine tune it to learn a brand new programming language? Well, today we're going to do just that. So I'm going to teach it a language it has never seen before and it has no idea how to program. And that language is called OPL, which stands for Open Programming Language or Organizer Programming Language. It's from 1984 and it's for programming the old Psion organizers. So today we're going to learn how you can then teach the llama model any programming language it doesn't understand. So let's get started. If you've never heard of the Psion organizer or you've never heard of the OPL programming language, it actually goes far back as 1984 and it was really popular throughout the 80s and into early 90s. In fact, I have a Psion organizer here and this is really cool. It flips open and you've got the keyboard. It's like an early BlackBerry, right? It's very, very cool. But you could program this thing using a language called OPL. And llama-2 has no clue about that, and what we're going to do is we're going to teach it OPL language. Now, if we look at the Wikipedia entry here, I just want to get you a little bit familiar with the language, and then we're going to start working with llama model, and then we're going to go and fine tune it to make it work. So you can kind of see here at a kind of simple level, here it is. Functions are actually called procedures. It's called proc. Then you put the name of the procedure, in this case main, and then just to tell it that the body of the procedure is coming, it's got this sort of colon there. It's new line terminated, so you can kind of see print and then hello world. So, you know, if you're used to something like kind of Python or basic or something, that's going to look fairly familiar. And then pause says just wait a little bit, pause for sort of 40 milliseconds before you continue on to the next piece. I think it's milliseconds, it could be something else. And then to end the procedure is end P. So it's got that sort of very old vibe, like if you've seen kind of, whens or, ends, etc. So very old language, very, very cool. Yep. And then if you want to be able to put comments in it, for example, it actually uses rem. So rem for remark. And you would just, so rather than doing a // it would be rem and then whatever the comment is. So that is the language. It's much more complicated than that. This is not a video about OPL. This is about how to fine tune a llama model using Google Colab to learn a brand new language. So we are going to get straight into that. So the first thing is, before we fine tune on Colab, I just want to show you that it has no clue. And I'm going to connect up to a thing called pocom, which allows you to connect to multiple large language models. So if I just click on more, for example, and you can see that there's two models. There's the llama-2 70B and then there's the llama-2 7B. So we'll show it working with llama-2 70B first, and then we'll go down to the 7B model because that's what we're going to train. So I'm going to open up llama-2 70B, and if I say something like, write me a hello world program in Psion OPL programming language, you're going to see that it hasn't got a clue. So there you go. You can see it's kind of hallucinated this completely. Certainly here's a hello world program in Psion OPL, const var string hello world, proc display, and it hasn't got a clue, right? And that's the llama-2 70B model. Now, if I want to, I can actually guide this just through a little bit of prompt engineering. And this exact type of prompt engineering is what we are going to use when we train the llama-2 7B model. So I'm going to open up my Visual Studio Code for a second. And what you are going to see in front of you is I'm using this technique, and it's a very cool technique, where I'm essentially giving it instructions of what I want to do. So you can see here in OPL, the print statement is used to display output to the screen. For example, print hello world, and then my example completion is print I will be displayed to the screen. And then I'm saying in the OPL programming language, keywords should be written in uppercase. For example, print should be in capital letters, completion, print is a keyword. Now, if we continue on, I said we were going to do something about comments. In the OPL programming language, comments are represented by the rem keyword, remark. Yep, rem is short for remark. Rem is implemented as a single line comment. For example, this is a comment. And you can see the technique that I'm doing. I'm just telling the model each time what I want. I'm saying, here is my rule, comments represented by rem keyword. Comments can be placed anywhere in a line using the rem keywords. Comments are not multi-line. A new rem statement is required for each new line of code. And you can see I just keep going, doing that and doing that and doing that. And then I've got rules for variable assignments. I've got rules for what a procedure is. I've got rule for the operators. I've got rules for comparison functions. It's just rule, 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 followed by example. Okay, so now all I'm going to do is paste all of those prompts into the llama-70B model in Po. And then it's going to give me a bunch of stuff. Yeah, okay, I understand the completions. It's giving me some examples. So it's really taking those instructions and it now should be able to program in that. So if I want to, I can test that out. I can say something like, write me a limerick in using comments only in the Psion OPL programming language. Now that we type that, here we go. Here's a limerick using comments only in the Psion OPL programming language. Ram, there once was a man from Kent who had a very large rent. He said with a grin, I'll have to win a game of chance to pay his rent. That's actually not bad. But remember, before it couldn't manage that. Now I can even do write me a hello world. And then it will probably get the print. So there you go, print hello world. So before it knew nothing about the OPL programming language, but now just with a few prompts has got it. Now, of course, my rules are getting huge. So I've got lots and lots of rules. The problem is that, I don't want to prompt that every time and lose my context window. So what I want to be able to do is now fine tune a model so it remembers my rules and now I've learned the OPL programming language. And that's what we're going to do now. Now, before we do that, I just want to test that this works with the llama-2 7B model, which is a tiny model, but that's what we're going to be able to run on Google Colab. So we will come back into po.com here for a second, and I'm going to select more, and then I'm going to pick llama-2 7B, and then we're just going to paste in the same stuff again, just to make sure it works. Now, the 7B model is less capable, so we'll probably need more prompts and more fine-tunes, more training to get it right, but it will learn it over time. Okay, now that it's got that, I can say something like, write me hello world in Psion OPL programming language. There you go. So it's now got the fact that it's going to do a print hello world. Now, it's not as capable as the 70B model. It would require a lot more training. It's not as smart a model as 70B, but the 7B model, as you can see, has been, I've been able to prompt engineer to get a good enough result. So now I should be able to fine tune that same model to try and learn a programming language. Now, of course, the same techniques that I'm using here could also be used for something like the Falcon 13B model, which again is a bigger model, or even you could use the llama-2 13B model. But we're going to use the 7B model because it's a small model. So how are we going to do that? So the first thing that we're going to do is we're going to go into Google Colab. I will share the link for this Colab Jupyter notebook that I've created. Again, I have another video where I go through how to fine-tune models. In that case, it was the Falcon 30B model. I'm not going to spend too much time talking about fine-tuning. I will probably do a whole video where I really break down things in detail, but I just want you to show that this is kind of working. So you can use my notebook and then you can just follow it from there. So I'm going to click on Connect here. And it's going to use the T4 model underneath there. So the T4 model will be small enough to be able to run 7B. Okay, so now that my T4 is enabled, we're going to install the dependencies. So the dependencies that I need is going to be, I need the HuggingFace, accelerate, PEFT, and transformers. I need bits and bytes for quantization. So what quantization does is it allows you to take a much larger model and be able to quantize it so it can run on a smaller GPU than you would normally be able to run this on. So, and again, I'll do a video explaining quantization properly, but it's just allowing you to run this on the T4 model. We're using PEFT. So PEFT stands for parameter efficient fine tuning, and it allows us to be able to take one of these large base models like llama-2, and then rather than having to fine tune the whole model, it essentially freezes all the parameters, and then we are just fine tuning the task layer. So that means that we get a much faster fine tune, and we're able to run this on, in a short amount of time comparatively to when we would have been fine tuning it, without PEFT, which would effectively mean you would actually be fine tuning the whole model. So it's going to take a long time and a lot of GPU. So PEFT allows you to do this really, really quickly. And then when you combine it with quantization, then you can run it on a small GPU. So I'm running it on T4, which is essentially free. And again, there's a few things I've added in. I've put in the sentence piece for llama-2 because I want to use the slow tokenizer. So I just need that library here. And then I need this SFT library, which is TRL in there. And of course I need datasets. So I want to be able to load my dataset that we're going to create from HuggingFace. So that's the dependencies that I need. So I'm just going to install them. Okay, now that that's installed, we can move to the next section. So what we are going to do here is I just want to set some parameters. So this will take a second. I am going to download the llama-2 7B model with the chat fine-tunings from HuggingFace. Now, if you go to Noose Research llama-2 7B chat HF, then you won't need to sign up for and do all the authorizations to use the Meta Llama models. Of course, the best thing for you to use is the Meta Llama models, and then you have to do all the signups, etc. But if you want to just sort of test this quickly, if you use the Noose Research one, then you don't need to do that. And then I'm going to give my dataset a name. Or I'm going to download a dataset from HuggingFace. So in HuggingFace, again, I'm not going to cover this too much. Sign up to HuggingFace, and then essentially you can upload your own dataset. I'll show you how to do that here, but you can see that I've created a dataset and within my sort of organization, which is Chris Hay UK, and then I can upload a file just by clicking add file, upload file. So I've got this train.jsonl file in here. So you can see here, Chris Hay UK test is going to download that train.jsonl. And then eventually the model I'm going to create is called llama-2 7B chuck test. And then I'm going to stick this in the results directory. Now, in order to make this work, because it's got a small set of data, is really quite small, I'm going to run this for 20 training epochs, right? So it's quite a lot of training that it has to do. It's just going to train it over and over again. If you've got a larger data set with more examples, you could bring that down to maybe like a number 5. But I think this will probably work in this case. So it's a little bit of overtraining, but it's going to give me what I need. Now, next, so we've run that. So the next thing that we are going to do is we're using Torch, obviously. I'm going to use auto tokenize. I'm going to use bits and bytes. Essentially, this piece here, again, I'll do a proper video at some point. But essentially what I'm asking it to do is this 4-bit quantization. I'm not going to use double quantization in this case. So this is me just setting up my config. And in this case, I'm going to use the auto model for causal LLM. So this is what you use for when you're, I just want to use an automatic large language model. I wanted to load a pre-trained model. So in this case, I'm passing through my model name, which was the Noose Research, etc. I'm asking it to use quantization with this config, 4-bit quantization, and then I'm wanting it to use a single GPU. So that's the device map here. I don't want it to use the cache, and then I want it here, you see tokenizer equals auto tokenizer from pre-trained. So what I'm actually saying here is go and use whatever the tokenizer of the model is. So it will take the model name and then it will understand which tokenizer it needs to use. So underneath the hood, llama-2 has a special method of tokenization. It's based on sentence piece. I will talk about that in another video. I'll show you what the format looks like here. You need to have trust remote code equals true. And then in this case, I've switched off fast tokenization, hence why I needed to put sentence piece on there. I had a little problem with the fast tokenizer. It may work, it may not, but I switched it off in this particular case. The next thing that you need to do, we'll explain this, is it needs the tokenizer. You need to set the pad token to tokenize the EOS token. That's so that it works with the llama-2 method of tokenizing. And then you need to set the tokenizer's padding side is right. So that's just a couple of things you need to do. And then once you do that, that's going to work. Now that I'm running this, it's going to go and download that rather large base model. But once that base model is downloaded, then we can do a few tests with it. Alrighty, so now that it's downloaded the model, and it's fairly large, right? You can see it's like 15 gigs worth of model or something like that I've got to download. So it takes a little bit of time. On my machine, it took a few seconds. So I've now got the base model llama-2 7B running on this machine in my Google Colab on T4. So now, before I train the model, I just want to test the model runs. So again, if we look here, I've got a bunch of prompts here, so I'm asking it who was involved in creation, etc. But actually, we're just going to use this write a hello world program in the OPL programming language. For a little bit of speed, I'm using pipeline here to do the text generation. And you can see I'm setting the task as text generation. I'm passing the model, which is the model that we've just downloaded. I'm using the tokenizer that we just set from earlier. And then max length is 200, so I don't want it to create too much. Right? And this is the key part, right? So this is write hello world in the OPL programming language. And you see that what I'm doing is passing through this prompt here, but I've wrapped it in this inst. So inst stands for obviously instruction. You've got to essentially wrap your prompt within inst. And then of course, the way that this works is it needs this s over here. So this is the method that llama-2 uses for both fine tuning, but also for running your prompts and running inference, running completions. So if I now run this, it will take a little bit of time. I should get a similar result to what I got when I ran this via Po. So when we run this, we are going to be able to see that the model really knows nothing about the Psion OPL programming language. Okay, so as you can see here from the instruction, it says write hello world programming in the OPL programming language, and then it says the OPL optimizing programming language is a fictional programming language is created for the purpose of this exercise. Here is an example. So, it's got, begin, which we know is not the case. It's a proc, etc. It's got the print right, but then it's just making this up. It's put a semicolon on there. It really doesn't have a clue. And then if I ask it to write comments and stuff, it's just going to utterly fail at this. So it doesn't know OPL. It knows nothing about it. So what we're now going to do is we are going to train the model, and then we can rerun that test. So in order to do that, we need to we need to load our data set. And I'm going to load our data set from HuggingFace. Remember, it was coming from my Chris Hay UK test repo there. And then I want it to pull train. So if I go into this test model here, you can see on the dataset card, so you will need to sign up for OPL, but you can see I've created a training file here. And then it's just a list of prompts. What does OPL stand for in the OPL programming language? OPL is short for Open Programming Language. So I'm actually telling it a little bit about OPL. What was the first implementation of OPL? The first implementation was in 1984 for the Psion organizer. And then down here is the same instructions that I showed you before. In OPL, comments are represented by the rem keyword. Rem is short for remark. Rem is this, blah, 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 blah. So this is my sort of 43 lines of instructions telling it what to do. So back to my point, if I was using prompt engineering, I would probably bust my context window. Whereas this way I can train the model, it will remember it, and I don't need to prompt engineer it so hard. But all of this is essentially from this JSON-L here. So now you're probably thinking to yourself, hang on, Chris, you're using prompt completion all the way down here. That is fine. What I've done is I've written a nice little Python routine that goes through all of my JSON-L files, and then I just convert it into this sint format. So eventually I end up with this train.jsonl, where it has all of this in, write a comment, in OPL, it does this, blah, blah, blah. So I have essentially 3 files that I've combined. I've combined the one that you saw before, which is all my statements about what the language does, where I tell about the rules and I give it some examples. The second thing I've given it is a set of prompts, which is what does OPL stand for in the OPL programming language, which company developed the OPL programming. So it's just prompt completions on, questions and answers about the language. And then the last thing I've given is a set of examples, right? Which is write a comment in Psion OPL, rem I am a comment. So I'm reinforcing all the instructions that I gave earlier, the rules, but I'm reinforcing it with programming examples. So this one does hello world, show me an inline comment, create me a program with a program header, including copyright, creating a program in OPL that asks the user their name and prints it to the screen, create an program in OPL that adds two numbers together, create a leap year, create an interest calculator, etc., etc. So you get the idea. So I've got three things. I've got a set of prompts that is going to tell me about Q&A, well, things about the language. I've got a set of prompts that tell it the rules of the language with examples. And then I've got an example set of common programming problems, which really bring the language to life. And then I've combined it all into this JSON-L here. And again, all I then do is go into HuggingFace, and then I can upload my files, add a file, and then I would just, if I want to, I can just drag my train.jsonl, and then we'll just click commit, and then it would upload in here. So now that I've got my JSON-L within here, what I want to do is fine tune this model. So really, again, I've fully scripted this out. I've been through what the imports are before. There's a few extra ones that I need, to essentially cover the training. So I've got HF argument parser, etc. That's fine. I've got this TRL for import SFT trainer. But this is very similar to before. I'm using this LoRa config, this PEFT config. So I'm saying I want to use LoRa alpha 16. I've got a dropout of 0.1. The R value is 64. Again, I'm not going to go through all of this today. I will do another video at some point where I really break down how fine tuning works. But I want you to just see that I'm using kind of 4-bit quantization. I'm using QLoRa in this sense, and I'm using parameter efficient fine tuning. Few things to point out. The epochs are going to be 20 in this case. It's using, all of this is pretty much standard stuff. I'm using a kind of 4 as my batch size. The accumulation steps is 2 because we're using small batches. This is all sort of standard set of values, so you don't need to worry about it too much. You can just copy the results that you've got. Again, in another video, I'll cover that in a little bit more detail. And then, of course, I'm just saying the model that I'm going to be utilizing. I've got no max sequence length. I want it to use the llama tokenizer. I want it to use the training arguments, etc. But the key thing is I'm going to train the model, and then once it's trained, I'm going to save that trained model. So last thing I need to do now, just before I fine tune the model, I just need to load my data set, which you can see I'm going to just click on this. It will load my data set, and that takes that data set that we defined, loads it from HuggingFace. So again, that's now done. Now that we understand what all the fine tuning does, we can just run my code, and then it's going to go off and train that model. It'll take a little bit of time, but it will be pretty, maybe it will take a few minutes. But yeah, again, large data sets could take quite a while, 30 minutes, whatever. But this should take a few minutes to do the fine tuning. Alrighty, so as you can see, it's now completed. It took about 10 minutes to do the fine tuning, so it's not that long. Again, you could probably argue that I could have used less epochs there than the 20. Maybe you could have brought that down to probably around, 13, 14 epochs, which would have been fine. But anyway, it's trained now. So now if we want, we can start putting any sort of prompt in there. As long as it knows within the rules of the language, then it's going to work here. So I am just going to run this here. So in this case, I'm going to write a tax calculator in OPL. Again, some of these examples it may or may not have seen before. I can't remember what I put in there. As you see, it's come back with the results there. Again, I've run out of tokens in this particular case, which is fine. I could increase it there. But now you can see the difference. So, all right, it's seen an income tax calculator before, and you can argue that it's seen this kind of there. But again, any sort of programming problem, that is an OPL, it's going to be able to handle here. So you can see in this case, proc calculate taxes. So it understands what a proc is. It understands the body. You can see it's using local, which is the correct thing for variables in this sense. And by the way, it's even sensible enough not to use the kind of percent stuff there. But again, this is an example that is kind of seen before, and I could change that. And we'll run another prompt in a second to show this. So and then it says print out calculator, input your input. Then here's if and ifs, etc. pretty good stuff. So let's just change this slightly so that it's going to have something it's not seen before. So write a hello Chris program in Psion OPL. There we go. It came back and you see, right, hello, Chris program in Psion OPL. This is really good what it's came back with, right? So the first thing is it's understood the proc, so proc main, and there's the body. Local greeting dollar. This is really cool. So it's recognized, just in case you don't know the OPL language, but local is obviously variable declaration, but greeting here, dollar sign, that is actually indicates that it's a string. So it's got that absolutely spot on, right? Now it's made a couple of mistakes. It's thrown in this kind of bracket here, so it's not quite right. And then you can see it's put an NP in here. So if I fine tuned this 70B model, it would get this spot on. But what I would probably need to do, because the 7B is a smaller, less capable model, I probably need to do quite a lot more examples, but it could probably get enough of the language if we really pushed it in. It certainly could do code explanations off the back of this if I wanted it to. But actually, it's made a really good job. Again, more capable model. We'll try this with the 13B at some point, but it's certainly, if I fine-tune the 70B model, it would be getting this spot on. But actually, for such a small model, it's done a pretty good job there. It's got the prints. We'll ignore this for a second, and then print greeting dollar. So it actually knows how to print stuff here. Again, it should probably be doing an assignment rather than doing this. And then it's got a get for the weight, and then NP here. So it's not perfect, but if I fine-tuned the 70B model, it would get it. I think if I just gave it more and more examples, I remember I only gave it 43 examples, but if I gave it maybe up to 1,000 examples, which is really the number that you want to really teach out programming language properly, then I'm pretty convinced that even the 7B model would get this good. Again, maybe if I use the 13B model, again, it would be pretty good as well. But as you can see, if we go back to what we had originally, if I come back up to when we run the model over here, I mean, it couldn't even get what OPL was. It was like the OPL is a fictional language. It had begin end. The explanations were terrible. So here, if I come back here, it's got the fact that it's a Psion OPL language. It's got basic variables. It's got the structure of procedures. It's got the print. It's got the idea of strings. It's done a pretty good job, right? It's just, it would need more examples to do that. So anyway, so as you can see there, this is a pretty good job for such a tiny model, and you've got the technique now. So if you want to go and fine tune your own programming languages, then you are going to be able to do that. Or even if you just want to fine tune the Llama models to do things like Q&A, then you would be able to do that as well. So anyway, I hope this has been useful for you, and I hope you are going to go off and create some really interesting models. Anyway, speak to you in the next video.